Hello everyone. Let us now discuss how can we solve this problem. Count of interesting subarrays. So we are given with indexed array nums modulo and k, and a subarray is called as interesting if the count be the number of indices I in the range L to R as subarray is from L to R such that nums of I mod modulo is equal to k. Then count mod modulo is also is equal to k. Then it is called interesting subarrays. A subarray is so we need to return an integer, nothing but we need to return the count of interesting subarrays. Now the constants, let us see at the constants. Nums dot length will be from 1 to 1e5, nums of I will be from 1 to 1e9, modulo will be from 1 to 1e9, and k can be from 0 and till less than modulo. Let us see by taking another example other than that given in the question. Right, modulo is given as 5, k is 3, and the nums are given as 3, 8, 13, 7, 1, 3. I randomly take this subarray, just taking this subarray. Now let us see. Now, if I want to repeat that, count is nothing but number of elements. Number of elements. Where element is nothing but nums of I, right? That element modulo should be equal to k. And if this count, I will get something like a count here for this subarray, and if that count, I will write that here, if that count modulo is also is equal to k, then this will be set as an interesting subarray. But before that, I don't know whether it is an interesting subarray or not. Let me write and go through every nums of I in this subarray, just in this subarray. Right, I have, first thing I have 8. 8 is nothing but nums of I. Percentile, sorry, modulo. What is this modulo? Modulo is 5. Okay, modulo is 5. Okay, is equal to 8 mod 5 is equal to 3. Okay, this is, yes, it is correct, right? So the count will be incremented, but let us be go to the next element, which is 13, right? So 13, wait a second, 13 mod 5 is equal to 3. Whether is it equal to 3? It is equal to 3. So it will be contributing to the count. Now let me go to the next element, which is 7. 7 mod 5 is equal to 2, right? So here 2 is not is equal to k. K value is 3, right? So 2 is not equal to k. So let me skip it. Now I have 1. 1 mod 5 is equal to 1, which is not equal to k. So let me go to the next element, which is 3. 3 mod 5, whether is it equal to 3? Yes, absolutely yes. Now I am in the right track. Here 8 is contributing to the count. So let me take count is equal to 0. Now let us take 8 is contributing to the count. Why? Because nums of I modulo is equal to k. Yes, yes, it is right. So count is incremented by 1. Now let us see, 13 is also contributing to the count. So count plus plus. Now I have 7. Is it contributing to the count? No. Why? Because nums of I modulo is not equal to k. So it's not contributing to the count. Next, it is also not contributing to the count. Why? Because nums of I modulo is not equal to k. Now let me go here. Yes, it is contributing to the count as nums of I modulo is equal to k. Now, okay, the count till now is 3. Now let us see. Here I got something like this condition if it is satisfied. Now I got the count till now. If it is satisfied, I will call this as interesting subarray, and let us see whether it is an interesting subarray or not. Now count is 3, so I am writing it 3. Right, wait a second. uh, wait a second, 3 mod modulo is 5 should be equal to k. K is nothing but 3. Whether is it equal to 3? Absolutely yes. So count mod modulo should be equal to k, and also nums of I mod modulo is equal to k. So if nums I mod modulo is equal to k, then it will increment count, and count mod modulo is equal to k, then it will wait a second, then it will increment the result. I think it's quite clear right now. Okay, so result will be incremented. So result is nothing but the number of interesting subarrays. I think for now it is clear. Let us go and just take how I can solve this problem. I am just naming it as pre. I'll tell you why I am naming it as pre. Okay, 3, 8, 13, 7, 1, 3. I am just taking whether I have nums of I contributing to the count or not. Now, 3 mod 5 is equal to k. Let us see. Let me write it. Wait a second. 3 mod 5 should be equal to 3, right? Whether is it equal to 3? Yes. So here it will be incremented by 1. What I am doing here? I am sorry, I have forgotten. So this is nothing but the prefix sum. I'll tell you what it will be, but for now it will be initialized with zeros everywhere, and if nums I modulo is equal to k, nums of I modulo is equal to k, then at that index only I am incrementing the count, just incrementing by 1. Now 3 mod modulo is equal to 3. Whether is it correct? Yes, it is correct. Now let us go to the next element, which is 8. 8 mod 5 is equal to, let us just write is equal to 3. Yes, it is equal to, what is the value of k? K is nothing but, wait a second, k is nothing but k is equal to 3, right? Now I am taking this k out. I am checking whether uh, nums of I modulo is equal to k or not. So 8 mod 5 is equal to 3. So I am incrementing the count for this index, right? Now I have 13 as the next element, right? 13 mod 5 is equal to 3, right? Now is it equal to k? Yes, it is equal to k. So I am incrementing the count. Now let me not so I am taking 7, right? 7 mod 5 is equal to 2. Whether is it equal to k? No. So the count will be as it is. Now I am taking 1. Now let us see what happens here. So I am taking 1. 1 mod 5 is equal to 1. Whether is it equal to k? No. Now I have 3, right? I am taking 3. 3 mod 5 is equal to 3. So I just increment the count for that index. I'll get 1. Now k is, so this is the prefix sum. As I said, I am taking the prefix sum for this array. I'll tell you what I am taking, right? Prefix sum is nothing but adding the previous element to the current element. 2 plus 1 will be 3. 3 plus 0 is equal to 3. 3 plus 0 is again equal to 3. 3 plus 1 is equal to 4. Now, here comes the question, how can I get a subarray which is interesting? I am taking this subarray, right? Now, what I am taking is, here it will be R, here it will be L. Just take this as count, right? So I need something like whether this is the count. This is the count. Now, how do I get this count? Count is nothing but, I'll write it here. Pre of R minus pre of L minus 1. Whether so this is nothing but count. Now if this count modulo is equal to k, then I will increment my result. So This is the whole intuition for this question. That's it. But the problem is, how do I write the algorithm for this L and R? But just take this L and R for a moment out of our box. Just think that 4 minus, here I got 1. Okay, 4 minus 1, I got something like 3. 3 modulo is nothing but 5. So mod, I am doing nothing but with modulo with mod with modulo, and I am getting k. I'll write the same thing here, is equal to 3, right? I think it's clear for you for now. Now imagine, just imagine, what if I got this one previously, right? What if I know this one? Okay, just imagine something like I don't have just one here. Okay, I think I have, just imagine I have more than one time. Okay, just be clear that here this is my prism of I. I'm just copying it again. I'm just copying it again. So this is nothing but my prism of I. This is prism of I, right? So what I am doing here? So I am doing prism of I minus, I don't know some value I am removing, right? So I am removing some value, and I am taking this modulo should be equal to k. Okay, now I need this value. I need this value. Okay, I need this value, but I am confused. How do I get it? Just the simple math that I got when I studied in my 10th class, that if you don't know something and you need to find something, then it will be x. Okay, pre-sum of I minus x mod modulo is equal to k. Now, do I want this x or do I need the count? I'll tell you. But before that, I am just taking pre-sum of I minus x so that I will get the number of subarrays. Now, let me say that I have 4, right? I have 4. Now, imagine I have 1 here. Now, this subarray is also an interesting subarray. Now, I am saying this. I am saying this. This subarray will also be an interesting subarray. Why? Because here nums of the count uh, pre-sum of r minus pre-sum of L minus r. Here it will be the L. Here it will be the r. Pre-sum of r minus pre-sum of L minus 1 will be 3 again, right? So I need the value. I need the value. Here I got 1. So here I got 1. So how many times this value is coming, right? How many times is this x? Previously, I got this previously. So if I got that, then that's what the frequency of x is added to the result. I am writing, or I am saying this again. So frequency of x, I think instead of x I will tell you that target, frequency of target is what I need, and I am adding that to the result. Okay, for now, right? Prism of I got. Okay, so I will just change it a little bit with my mathematics. Modulo, right? Minus, but before that I am saying this, right? Minus x mod modulo is equal to k. I'll tell you what happens here. So here I have like this, something like this. Now what I need, x. Let me take that into the another part. All right, x modulo is equal to ps of I mod modulo minus k. I think if you have passed your 10th class, it will be so simple, and I don't need to explain how this step came. The next step is much important. PS of I, let me take the first value. PS of I got 1. So let me remove all these things, all this stuff, right? Okay. I got first element as 2, PS of I as 2. Sorry, 1, right? 1. Mod, what is the modulo value? I think it's 5, right? Modulo is 5 and K is 3. Let me write it. Modulo is 5 and K is 3. Now, why I am doing this? If I just got this, if this is my target, right? This is my target, and I know how many times I got the target, then I will add frequency of target to the result. So this is how I solve this problem, right? You might be confused again. Let me just recap. I'll just take this subarray and I am taking this as an interesting subarray. But if I also have this one again, so there is no chance that the x will be for only one time. That's why I am taking the number of times I got the x value, the number of times I got the x value, then I will increment that result by the number of times I got the x value. I think it's clear for now, right? Result plus is equal to frequency of target. Instead of asking for x, I just asked for target. Target is nothing but this one, PS, pre-sum of I mod modulo minus k. Now 1 mod 5 is 1, minus 3 is nothing but minus 2. You might say minus 2, should I have to ask for this minus 2 in a unordered map or a frequency map till now? So if I got something like minus 2, then I will not get the answer, the correct answer, right? So that's why what I am doing, and most of the people, if you have looked at their solutions and something like in an editorial, they are doing nothing but they are taking out this modulo. Wait a second, I'll just copy this minus k, and they are adding this modulo, and they are doing mod modulo. You might wonder, right? Okay, by adding modulo, what did you gain, right? What did you gain, right? You might ask me like that. So PS of I value might be from, I think, I just don't care what is the p or a p, the prism of I value. I am telling you that this value will not exceed, right? This value, right? 5 is the modulo value, and 1 or 1 not 1. If I do this, I will get 1. If I do any time, I will get either these values 0, 1, 2, 3, 5, 4. I'll not get 5. If I got a number 5, it is nothing but it's 0. It's simple math, right? If I got 100, right, for this, then I will get modulo mod modulo will be 0, right? Which I wrote here. So the range will be from 0 to 4. 0 to 4, right? So instead of not, as I am going to the negative value, so that's why I have added plus modulo. So it will not let us go to the negative values. Now you might wonder, right? Here I got, let me write the same way as it is before. Here I think it's here as it is in the before. Now let us say PS of I is 1 not 1. Prism of I is 1 not 1. This is PS of I, and the modulo I need, I know that modulo is 5 and K is 3. Let me say that these two are equal. I am saying that these two are equal. So when I say that I need to prove it, I am proving it now. PS of I is 1 mod 5 mod 5 minus 3, what it will give me? 101, sorry, right? I need to take something like 4. It is going, as I said, it is going out of bounds. Right, it is now clear. 104 modulo 5. Modulo 5 is 4. 4 minus 3 is 1. Let me check whether I wrote this one, right? 104 minus k is nothing but 3 plus modulo is 5 mod 5 again, right? Mod 5 again. 104 minus 3 is 101. I think it's clear for now. When I got 101, I got minus 2. But here, as I am adding 5, 101 plus 5 mod 5 again. 101 plus 5 is 106. Mod 5 will give you 1. Check it. These both are equal, so that's why I am taking this. And let me just skip to the algorithm part, right? So the algorithm is something like presum will be initialized, wait a second, presum is initialized with n comma 0, and for int I is equal to 0, I is less than n, I plus plus, and if here nums of I mod modulo is equal to k, then presum of I plus plus. And I know you can even optimize this, but for the time constraints I am not doing that. So nums of I am starting from I is equal to 1, and presum presum of I plus is equal to presum of I minus 1. I am clear for now. Now I am taking an unordered map with long, even I can take just int comma long with I am storing it as empty. Okay, now I am iterating for int I is equal to 0, I is less than n, I plus plus, and the target, as I said, target is equal to nothing but presum of, I'll tell you, presum of I minus k plus modulo percentile, sorry, modulo. This is my target, and I will add that frequency. I'll get that frequency from this target, and I know it's completed, but I am asking for this target is x mod modulo. So x mod modulo, that's what I am asking for in the target. Now when I am storing in my MP, I also store in the same way presum of, wait a second, presum of I mod modulo, so that I am not uh, adding x. Instead I am adding x mod modulo, right? Is it clear? So I'll return the result, but before that let me not forget to initialize this result is equal to 0. Is there anything I missed? And if you didn't even understand and if you want any further explanation, and I will definitely make you understand this if you DM me in the LinkedIn, and you can even comment if you want to, and do like, share and subscribe to my channel. Thank you.